Alright, today we're going to be going over reduction formulas. So the first formula we have is the integral of sine to the power of n of x. So this can be used to replace any equation you see with sine. So let's say we have an equation that's sine to the power of 3 to the x. Wherever you see an n in this equation, you're able to just replace it with whatever the sign is to the power of, and you'll have the answer. So sine to the power of n of x is equal to negative 1 over sine to the power of n minus 1 of x multiplied by cos x plus n minus 1 divided by n multiplied by the integral of sine to the power of n minus 2 of x. Now, for this reduction formula for cosine to the power of n, you can use this in the same way as the sine reduction formula. Whenever we have a question such as the integral of cos to the power of 4x, whenever we see a 4 here or any number in the exponent, you can replace it with wherever you see an n in the reduction formula, and then you'll be able to simplify it and get your answer. So the cosine reduction formula is 1 over n rather than negative 1 over n, cos to the n minus 1 multiplied by sine x plus n minus 1 divided by n multiplied by the integral of cos to the power of n minus 2. Alright, so our first question is sine to the power of 2 of x. Now we're going to put this into terms of our reduction formula. So if you need to go back to check it out, or if you have it written down, we know that it is negative 1 over n to start, but our n in this case is going to be 2. So anytime we have an n, we're going to replace it with 2. So we'll have 1/2 sine to the 2 minus 1 of x multiplied by cos of x plus, and this is going to be 2 minus 1 divided by 2 multiplied by the integral of sine to the power of 2 minus 2 x multiplied by dx. Now, to simplify it, we can have this negative 1/2 sine of x, because 2 minus 1 is 1, which just means it's regular sine of x, multiplied by cos of x, plus 1/2, and then it's the integral of sine to the power of 0. But anything to the power of 0 is 1, so we're going to have the integral of 1 multiplied by dx. Now, this gives us negative 1/2 sine of x multiplied by cos of x plus 1/2, and the integral of 1 just becomes x. And if you really want to, you can factor out the 1/2, giving us 1/2 of negative sine of x multiplied by cos x plus x. Our second question is the integral of cosine to the power of 4 of x. So to start off with the reduction formula, we're going to have 1 over, instead of n, it's going to be 4, multiplied by cosine to the 4 minus 1 of x, multiplied by sine of x, plus 4 minus 1 divided by 4, multiplied by the integral of cosine of 4 minus 2 of x multiplied by dx. Now this will give us 1/4 multiplied by cosine cubed of x multiplied by sine of x plus 3/4 of, this will be cosine squared, so if we want to, we can use the reduction formula again, but instead of it being cosine to the 4, it's going to be the integral of cosine squared of x, which will give us, instead of an integral here, we're going to have a bracket of 1/2 multiplied by cosine of x multiplied by sine of x plus 1/2 of cosine squared minus 2, which just gives us the integral of 1 multiplied by dx, which just turns into x. Now to simplify it, we will have 1/4 multiplied by cosine cubed of x multiplied by sine of x plus, and we're going to put the 3/4 in, so multiply it is going to be 3/8 cosine x multiplied by sine of x plus 1, that's going to be 3/8 of x, and making sure at the end to add our plus c as our random constant that could be added at the end of the integral.